Hello, hi everybody. In the morning, when I was solving one of the question, when I was proving one of the question using convergence series, I realized I made a little, just a small mistakes. So I'm gonna correct the mistake first before we go further, and then we prove the P series test. I realized I make some little mistakes, so I couldn't go back and start to solve all the question afresh because of the time, but just a little, just a sign. So I'll just say that I believe you understand. So let's go to the business, right? Just like I said, it's Mntwana Wa Bantu Academy, and just before you get started, when you finish, make sure you click the like button there and also subscribe so that you can get more video, right? This is like non-profit organization, and you can always get free video rate, right? If you think I deserve to get like button and subscribe, make sure you click there, man. Thank you very much, I appreciate it. Let's get back to the business. Thank you. Just me. So now, just a second, right? And thanks a lot, I appreciate for your patience. Let's go to the business. Okay, so the little mistake I make, I can't say little because everything is important here when you do when you solve. So but like I said, you can also learn from a mistake. So feel free always correct me whenever you feel like there's a need to. Okay, cool. So take the P series by convergence. So the mistake I did it before is that on a P series test, whenever P is greater than on a P series test, when P is greater than 0, and then the series converge. When P is greater than 0, the series converge, and then when P is less than 0, and the series diverge. So, okay, Hamish, what is the mistake you did? On the previous question, the mistake I did, I say when P is greater or equal than 0, and then the series converge, which is not true, right? It has to be greater, only greater. So that's a mistake I made over there. So that has to be greater, my apologies. So this has to be only greater, not equal. Okay? Thank you so much for understanding. So let's get back to the business, right? So just remember that, right? Keep it notes. When P is greater than 0, series converge. When P less than 0, series diverge. Let's go back to the equation. So let's taste the P series. Let me prove let's prove the P. Let's taste the P series by convergence. Let's get to the business. So how we do the Hamish? Taste the P series by convergence. See that? Test P series by convergence. So let's test the P series by convergence. So test the P series by convergence. Test the P series by convergence. So how we do that? Let's assume we have a summation of a number. Means you sum a certain terms like 1 xp plus 1. No, let's say 1. Let's say 1 2p. And then, okay, so it's 1 2p, or let's say 1 of a function. Okay, let me just make it easy. Let's say have a 1 xp, mean this is our term or function. So now we want to sum all the term, but those term has to be value of x start from 1 to infinity. So what does that mean? If I had to plug it in, means it has to be 1 x is 1 power p plus. Now we increase this value of x because say we add the number from 1. Why do we plus? Because of this sum here. So we say 1, so x now is not going to be 1, it's going to be p because it's going to be 2 because we increase this x from 1 to infinity. So 2 power p. Now let's go. So 1 over what we sum because of this sign here. So 1 over 3 power p plus 1 over 4 power p plus da 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 da. We don't know where we're going to start because we haven't finished. So the last term should be, we don't want to, because we're going to continue, we don't know where we're going to start. But if I had to put, and I'll say is 1 over, what is the last term? Infinity power p. That means continue 1000, 1 over 1000 power p, 1 over, you know what I'm saying, until the last term, which is infinity power p. Okay, so I'm gonna say we want to prove the P series by convergence, like I say, right? So we're gonna say now, excuse me. So now we're gonna say, if somebody give you, right, sum of x equal to 1 to infinity, 1 over xp, mean this is my function. This is the same as say mathematical, so I say integral, and then what is my limit? Limit start from 1 to infinity, 1 to infinity, and then I'm going to write my function here. So xp dx. Why you say dx? Because you're going to integrate the x. This p is any constant number, so that's why I only integrate x. That's what I say dx. Let's go to the business. So now this is infinite integral, means doesn't have end. We integrate a limit from 1 to infinity. So when you integrate, most of the time we want to know the limits, like from beginning to an end, but this one doesn't have an end, so we have to let any number. So we're going to say, okay, so I'm not going to use this infinity, I'm going to pick any term. So I'm going to say let, so I have to limit this term. Means I have to say 1 maybe to 5, 1 to 6, or 1 to 7, 1 to 8 when you integrate, because this we call integral, infinity integral. So this is infinity integral. Just in case if you're not saying this, let me know, I can make a video of infinity integral. So when you have infinity integral, we have to limit, or we have to change this number to infinity integral. So how we do that? We say, okay, let's limit in. I don't want this to be infinity, it has to be a certain end. So I'm going to say that n, or this it has to be equal to n. This has to be a certain number. I don't want it to be infinity, because that's how you change infinity integral to infinity. So because when I change to infinity, it's going to be easy for me to integrate. So I'm going to change this number to n. That's why I let n equal to infinity, and then I'm going to say integral. So start from 1 as it is, and then I'm not going to say infinity anymore, because I have limited this number to a certain term. I mean, it can be 5, 6, 7, 1, n number, but I wouldn't know which that number, so we assume it's n. So we say 1 to n, and then I'm going to write my function that is xp and the dp. So let's continue now, but a note. For some of the people who don't know how to integrate, first you have to reciprocate this number. So it's going to be limit, and then our n approach to infinity. Let me go quicker so that we can save time. And then integral 1 to n, and let's reciprocate. When you reciprocate n number, 1 over n number, take this number is, and then bring it up, and then change this sign. See, so it's going to be x, take the denominator the way how it is, and then this is p positive, so it's going to be negative p, and they say dp. We reciprocate there. We reciprocate. What is the reciprocation meaning? Okay, let me just show you quick how to reciprocate. Some of the people that might not know how to reciprocate means if somebody give 1 over x over Mntwana Wa Bantu Academy. So that's what you do. You say, okay, this same is say, take this as it is, and then I'll bring it up. So whichever number is there, you leave it there how it is, and then this one is positive. You see, x power m. So it's going to be x is positive, right? So it's going to be negative m. So finally, it's going to be x power negative m. So I'm saying, I hope everybody could see that. That's why this one here is 1 over x power p, and then when I reciprocate, it become x power negative p. So it's going to be easy for me to use the law of integration. Okay, so let's go next. Let's go next page, right? So I hope everybody could see that. So go next page. So next page, let's go continue. So now we have our limit n approaching infinity. Continue from right there. So 1 infinity, and then x negative p dp. Okay, let's continue now. So what we're going to do now, there's a rule of integration. Say, whenever integrate, let's say x power n dx, means you integrate this x. This is a constant number. This number faces should never be negative. Should never be negative 1 or negative, just a negative 1. Negative, not negative 1, not negative. It can be negative, but not negative 1, but not negative 1. So when you integrate this type of equation, you only take this, you say x, take this n plus 1, and then take exactly over n plus 1. That's all, and then you plus constant because you don't have a limit. One more example. So if somebody give me integral, let's say x, let's say power 4 dx. So what that mean? I'm only going to take this exactly 4, and then add 1, and then this one is falls apart. This one integral and dx, they fall apart because you do that process of integrate. So don't write them again. This integral and dx. 4 plus 1 is going to be 5, and then take this out again, it's going to be also 4 plus 1, my apology, and then you plus constant. Why? Because I don't have a limit. So if you don't have a limit, make sure you plus the constant. So this final is going to be x power 5 over 5 plus constant. You know what I'm saying? Okay, if you want more question, example of integral, you can tell me. Also, even if it's x, let's say 1 over x, let's say 4, so dx. So this same as say integral x, so I'm going to reciprocate this, going to be negative 4 dx, and this is going to be x, take negative 4, plus 1 over negative 4 plus 1, which is going to be x negative 3 over negative 3. So I'm saying, because this one you add negative 3 over negative 3, and then you can reciprocate if you want, which is going to be 1 over 3 x power positive 3. So but we're not here for integration. We're here to solve this question, testing the p integral test. So what we're going to do now for this case means this one from low integral, we're going to add 1. Hamish, why is negative? And you say whenever you integrate here, because according to how I explained here, say this should never be negative 1. This is not negative 1, this is negative p, so it's okay. Just like here, you see, this is negative 4, it's not negative 1, so it's okay. We just add 1, and then the same thing I added the denominator. So I'm going to say, okay, so let's take this one here. So I'm going to say limit, because it's still there, infinity, shows me. And then, now this one is going to be x negative p plus 1 over negative p plus 1. Hamish, where is the limit? We're not gonna. Where is plus c constant? We're not gonna plus constant because this integral has a limit. My apology, I made a mistake here a little bit. This should be n because you say limit n equal to infinity. So it has to be n, just like here. N, because you have limited n approach to infinity. So, excuse me. Okay, we go. So now we say, okay, so this one it has to be n, not infinity, because you have limited n approach to infinity right there. So if that's the case, here we go. So now this let me say limit n approach to infinity, and then I have an x. I can flip this if I want, means I can switch them because I don't like to put negative number before positive. So say 1 minus p, and then over 1 minus p as well. But I have my limit. What's my limit? 1 2, and here 1 2, and let me try to create a space here so it's not going to confuse you. Okay. So next page here. So now we're gonna have to we have to insert our limit inside this function. So this limit here, these are x's. Remember, these are limit of x's, not p. So we're gonna take this limit in position of x. So now we say, but remember this p is gonna be constant. It's like saying, excuse me, let me go slow. So limit n approach to infinity. This is same as say 1 minus p times x 1 minus p over, or just 1, yeah, same thing. So 1 minus p, so 1 to n. So you see this term is constant. Why I say it's constant? Because look, your limits 1 to n, and n, this limit is going to go in the position of x, not 1 over 1 over 1. So this is a constant, so this constant has to go behind. So 1 minus p has to go before everything, so because it's constant, so it's not going to be affected by this limit of function. So 1 minus p, and then the limit is going to follow after limit n approach to infinity, and then it's going to be x 1 minus p, and then just 1. So I don't even need to write 1, but I just write for funny, you know I like to do that, man. Mntwana Wa Bantu Academy, you always do that just for funny. So let's go. So what we do now, I'm gonna have to, from the law of limit, when you have an upper limit and lower limit, and you have simplified to, okay, I'm satisfied, here I'm satisfied. Now you can substitute this limit. So let me substitute in. So 1 minus p, and I have a limit and approach to infinity. So I'm gonna be done with here. So I'm gonna say, okay, put it in. So this is gonna be, I don't need 1 because like anything divided by 1 equal to 1. Mntwana Wa Bantu Academy divided by 1 equal to Mntwana Wa Bantu Academy. Anything divided by 1 equal to 1. 5 divided by 1, 5. 6 divided by 1, 5, 6. That's what we did grade 1, 2, 3, 4, 5. If you can't remember, let me know. I can make a video for grade 1, 2, 3, 4, 5. So n is going to come in here. And it's going to come in position of x. It's going to be n 1 minus p. So upper limit minus lower limit. What is the lower limit? 1. So we're going to substitute the position of x. So it's going to be 1 minus p. Okay, 1 minus p. I'll put like that. Something. Space here, so I mixed up. That was example. So now what follow is 1 power something, 1 power anything equal to 1. If you're taking Mntwana Wa Bantu Academy or Hamish here, power motherland equal to Hamish. So I'm saying, so if Hamish is 1 and the power motherland equal to Hamish, Hamish is 1 power Chicago means Hamish. So 1 power anything equal to 1. So this is gonna be 1 minus p. 1 minus p, excuse me. Limit, and then our n approach to infinity, and this gonna be n 1 minus p minus 1. We got it. So next step now, I can reciprocate this if I want. I want to do that, yes. Not if I want. I want to do that. Let's go. So 1 minus p, excuse me, and the limit n approach to infinity. So I'm gonna say when I reciprocate this. Before I reciprocate, let me say this. Okay, so this is going to be n. So here's like, let me put bracket together. 1 minus p minus 1. Let's go next page, please. Thank you for your patient understanding. There we go. So now, excuse me, let me recopy face and that will continue. Let's go back to red pen. Let's go to red pen. Excuse me. Okay, excuse me. Second page. Thank you for the patient. Okay, go. So now, let me rewrite face so it's not going to confuse you. So 1 minus p and the limit is the n approach to infinity, and there we have. Okay. So right there, you see. Excuse me. I don't know if people can see that. So n1 minus p. So I'm going to reciprocate. Remember, this is positive. So when I reciprocate, everything is going to have a negative. So I'm going to say 1 over exactly. But here, if it's positive, here is going to be negative. I hope everybody could see. You see, it was positive here. So when I reciprocate, it becomes negative. That's how you reciprocate. You put your bracket because there's 2 terms, and that's just going to be positive. And then when it turns, it's going to be 1 over exactly number, and then only thing you change is negative, and then minus 1. Bracket. Let's put this to the rest. Hey, you go and rest there. So here we go. So 1 minus p limit n approach to infinity, and then put your bracket. Excuse me. And now I can substitute in, so this is going to be n, put in negative 1 plus p, so I can say p minus 1, because it's going to be negative 1 and then plus p. So I always like to start with the plus. That's what my grade 1 student taught me when I was in grade R student, grade 1 and grade 2. So minus 1. So let's go now. So now we're here. So look, man, excuse me, n approach to bigger number. So if this number is bigger, I think we'll be seeing in the previous video, right? Previous video that where I said I made mistake when I say the series converge for the p states when p greater than. I forgot to say. Oh, don't worry about it. I think I explained it before. I say this is what I say. It should be p greater than 0, and the series converge, and p less than 0 series what diverge. So I made a mistake. I say p greater or equal to 0. No, p has to be greater than 0, p less than 0. So we say on the previous video, if you check in the previous video, we say whenever I have a one orange and then I have a lot of people. How do I know a lot of people? Because this n approach to infinity. When I say infinity, it means something bigger. Positive infinity means something bigger, positive. So if this is bigger, let's say 1,000. So 1 divided by 1,000. 1 orange divided by 1,000 people. What happened? Everybody's gonna get like, I don't know, maybe a little seed of, I don't know, even seed is bigger. So that's why we're gonna say this is gonna be 0. It's like 1 divided by 1,000. Trillion means you got $1. And how many people you have? 1,000, 1 trillion people. It's like everybody gonna get nothing, man. They're gonna get home with empty hands. No money in the bag, no money in the pocket. So that means all this is going to be 0 because 1 divided by something big. How do you know something big? Because this n approach to infinity. So if you substitute in here, means it's going to be something bigger. So now we limit means put this n here. It's going to be 1 divided by something very big. 1 divided by something very big, 0. So 1 minus p limit n approach to infinity. No, apology, because we substitute in, so we don't have to say n approach to infinity. So we just put straight away. So 1 minus p, and then this stuff here is going to be 0, minus 1. You know if it's 0. If you don't understand, please let me know. So this one is going to be 1 minus p, shows me, times negative 1. So we can substitute in here. So put it in. It's like negative 1 minus p, and now mathematically I could say 1. I will take this negative down. It's acceptable. So say negative 1 minus p mathematically, because I don't like my p to be. I can put it in, so I'll say okay. So put negative in, negative 1, positive p. So it's going to be 1, p minus 1. So I'm saying, so p minus 1. So we want to write the condition now. So our condition, we want to test now. So that's how we test p series test, right, for convergence and divergence. Let's test when p is greater than 0. What's going to happen here? Okay, let's plug in p greater than 0. What's p greater than 0? So for what we say from p series, that's what we're proving now. We said when p greater than 0, and then this is gonna converge. Let's see and prove it's true. So let's put a number. Let's say 1 or 2 or 3, and see if the series is true. We're gonna converge, and then after that we're gonna go for p less than 0. So let's divide here, and we say for this one is gonna converge. Apology, if you can see converge, and this is gonna diverge. Let's see if it's true. Now let's go p greater than 0. What that mean? P maybe 1, 2, 3. Let's do 2. Let's test for 2. Let's test for 3. Okay, let's say it's 2, so it's gonna be 1, we put it in here, we insert in here. So 2 minus 1 equal to 1. Okay, let's say it for 3. So it's going to be 1. 3 minus 1 equal to 2. Okay, let's test for 4. 4. So it's going to be 1. 4 minus 1 equal to 1 over 3. So let's look what happened here. This series here, this is called infinite series because when you start to say 1 to infinity. So this series here, we find out it's going to converge. Why? Because 1 divided by 1 is 1. 1 orange divided by 1 peso is 1 peso. And you have one chocolate, you divide by 2 children. So what happened? Means they're going to get 0.5. Okay, now you have 1 and the 3 children, means everyone is going to get 0.3. So you see, it's converge. My approach converge, it gets smaller and smaller and smaller. So for that reason, we have proved that when this p is greater than 0, it's true, it converge. Only when it's greater than 0, not equal, like what I said before. Because before I say when p is greater or equal. Greater, yes, agree, but when it's equal, no, it's not true. Because when it's equal, means when you put 1 here, it's going to be 1 minus 1. Look, let's see. Let's go p equal to 1. Let's see. When you put equal to 1, it's going to be 1. Excuse me, let me just do it here. It's going to be, let me use a black pen so you can see clear here. Okay, let's say p. Oh, this pen is getting down. Let's try it on. Here's my color. Okay, let's say p equal to 1. So if p equal to 1 here, let's put it in here. It's going to be 1 over 1 minus 1. So what happened? This is undefined because 1 divided by 0 is undefined. Put in the calculator, you see. It's like, hey, Mish, what you mean when you say it's undefined? Whenever you have a 0 at the bottom, there's no something going to exist. For example, you have a car. The car has no tire at the bottom. What that means? It's not going to exist. It's not going to exist. Somebody catch all your legs or catch all the piece of bottom of you, like down the bottom of you. How are you going to exist? No way you're going to exist. No way you're going to exist. Or for example, your house, this, like we human beings, right? If there was no head or there's no ground, how would we exist? We wouldn't exist. So that's why when anything at the bottom equal to 0 means it's undefined, means there's no such a thing. So that's what we say. So what I say from the previous lesson, that p equal greater than 0, it converge, not true. It has to be greater than 0. And then we have proof here. Now let's see for divergence. Let's say p is less than 0. If p is less than 0, what's going to happen here? So we take the same thing here. Excuse me. This is a black pen so you can see for now. So we say when p less than 0, say p equal to -1, -2, -3. So we substitute in here. Okay, let's start with the -1. So it's going to be 1 over -1 minus -1 equal to -2. Okay, let's go. Now -2. So it's going to be 1 over -2 minus 1, -3. So what we see here, this is going to be -0.5, and this is going to be -0.3. Excuse me. So which one is bigger between these two? This is bigger. This is smaller. Hey, Mish, what you mean? How can you say 0.5 negative is smaller and 0.3 negative is bigger? Look, man. If you owe somebody 100 rand and I owe somebody 200 rand, who is worth, like, who is a rich man? Like, it's not rich, like, who is better in this situation? So I'm saying, you owe somebody $100 or dollar or something, $100, and I owe somebody $300. So who's better? I mean, I think you're better because you owe that person less money. But I have to work hard to pay that $500. So that's why for the negative, the more the negative number is getting bigger, I mean that's means this is bigger, this smaller. Okay, let me say again because some of the people confuse them, right? Excuse me. -10. Okay, let's put a number line. This is 0, 1, 2, 3. Continue to positive infinity. -1, -2, -3. You have to know from now on, whenever you come from this side, the number is getting bigger. So -3 and -2, this is bigger compared to this. When you go farther, this is bigger compared to this. Don't look at the number, look the sign. So I'm saying, so the more the negative number, the number of the negative get bigger, means it's getting more smaller. So from this side, let me put it like this. These numbers are too smaller compared to this. So -3 and -2, this is bigger compared to this. So if you go back to the equation, excuse me, -5 and this is bigger compared to this one. So for that case, we see this series, it diverges, it's getting bigger. So when p is greater than 0, and this series diverge. So yes, we have proved using p series test that the series what? Diverge. Thank you very much for your time. And you know, I saw like, let me just prove this piece series taste. And if you have any question, please feel free, let me know. If you don't understand any suggestion or opinion, like I say, right, I have a limited resource, so I'm trying to do what I can just to assist people that are whatever I can, you know what I'm saying? So let me know, leave the comments. Like I said, don't forget to click button, share, and like button, subscribe. And by the way, right, my music, man, don't forget to support my music, man. My music gonna be, some of them they're out already, and you know, just get your CD, get your music, like button, subscribe. You know, that's how I do. When you like my music, when you support my music, and then we can keep project going. You know, this is, like I say, we help these to help girls, young girls, and you know, people from underprivileged family, you know, underprivileged community, just to, you know, tell them, because I was homeless for two years, you know what I'm saying? So to make people believe that they can do, so I'm saying, it doesn't matter where you're from, your dream can be valid, man, like Lupita, how she said. So thanks, man. Thank you for your time. I appreciate it. Leave the comments. Don't forget to subscribe. Any suggestion, opinion, leave the comments and get back to you. Thank you very much. Mntwana Wa Bantu Academy, man. That's how we do, baby. Thanks, man.